We're going to cover retinopathy. The bots seem to know quite a bit about it.
Diabetic retinopathy, doctor, is a diabetes-related eye condition that damages the blood vessels of the retina, the light-sensitive tissue at the back of the eye. It is one of the leading causes of vision loss and blindness among people with diabetes.
Yeah, we have symptoms, blood vision, diagnosis, detailed exam, optical coherent tomography. So we focusing, ask about specifically about the OCT, detailed imaging of the retina, how it works.
Optical Coherence Tomography, OCT, in diabetic retinopathy. What is OCT? Optical Coherence Tomography, OCT, is a non-invasive imaging test that provides high-resolution cross-sectional images of the retina. It works like an ultrasound, but uses light waves instead of sound to create detailed...
Okay, get the picture. So yeah, so here it gave a fairly detailed, I don't know how accurate, let me know if you're an expert, table comparison between normal retina and diabetic retina. So I have the differences there. We'll see an image of it in a sec. So symptoms, I told it to actually focus on the difference between normal and diabetic. Yeah, the table again. Red spots, yellowish spots, fragile new blood vessels, a thickened retina, swallowing. Yes, so it seemed to know quite a bit. We tried an image. So the question is if we can actually generate like synthetic data using one of those image generators. It seemed to do. There seem to be a lot of data sets, which we go over in a sec as well. That we can use, and wondering if we can just generate synthetic images, because then we can adjust for we can actually edit a specific image and add the abnormality in a certain location. You can actually select whatever this area. Let's say it should add some abnormalities in a specific area of the image. So wondering if we can generate synthetic data this way. And it will be a really useful question, like how accurate it will be. Yeah, it says here's an image of retina affected by diabetic retinopathy, but yeah, I don't see anything. Yeah, I'm getting confused with the images. The interface meant to be adding something there. No, I didn't actually do it. Yeah, I did like severe cases. Then actually asked it to add milder diabetic retinopathy, and then even very mild. So it did that. Okay, so I'm not sure how good these images are, so we're searching for relevant public datasets. Yeah, so we have Kaggle first on the list. It's not hallucinating any more links. It's actually providing accurate links. By the way, everything we do eventually appears on our website, so go check it out. We're working with different types of datasets, doing image analysis, and working with time series as well. So we're actually training our own models. Well, actually, this is time series turned into a spectrogram, so essentially image processing, and yeah, using image libraries for that. So we're doing similar stuff, but for different types of datasets. So go check out the website. There's some fun things on it as well. And so this dataset, yeah, closed, the competition closed back in 2015. So then you go Kaggle competition. Okay, if you look at the data, yeah, we have no diabetic retina, mild, moderate, severe, and another something. I assume it's like level 4. A problem with this dataset is that when you go download all, it sends you to, or even to begin with, it says license subject to competition rules. Essentially, when you go download all, it sends you to the rules. I can't be bothered reading all the rules, but essentially, if we ask the bot if the Kaggle competition is open source, it says this.
The dataset provided for the Kaggle Diabetic Retinopathy Detection Competition is not open source. According to the competition's rules, participants agree that their involvement does not grant them a license to the data, either explicitly or implicitly. This implies that the data is intended solely for use within the context of the competition and is not freely available for other purposes.
Right, so essentially, yeah, we would not be using that Kaggle dataset. What else we've got? We got this. Yeah, I'll come to this one in a sec, because that's the most promising. That's the one we will actually be using for this. Yeah, we have IEEE data, and as always with that with IEEE you actually have to log in as well. Can't download anything. Yeah, will probably cost money as well. So we're not using IEEE as well, unfortunately. Or fortunately, I don't know. Depends how you look at it. What else we got? We got this MedArchive. So MedArchive, yeah, it's a preprint server, so it's all open source. The dataset is available. Yes, there's some examples. Yeah, they look good. There's some benchmarking instead of the deep learning model. So that's actually what we want to do as well. And the code is available on GitHub, which is good, but I don't think code is necessary anymore, as long as you have all the prompts. Where's the link to the dataset as well? Yeah, right. So it's on Fionet. And on Fionet, again, some datasets are open source. But this one, you need the login, you need credentials and stuff. So probably signing some sort of agreement and stuff, which is highly undesirable. It says here public release, but if I don't see the download button, then it's not happening. And I don't actually see it. Yeah. Well, yeah, generally Fionet is as a platform is fine. It's just when someone uploads the data, they're essentially deciding what license it should have. And this one, yeah, it's Fionet credentiated health data license. Whatever that means, it doesn't look like really open source. So, unfortunately, yeah, see you later. What else we got? MedArchive, Archive, and now one. Let's quickly look at that. It's funny how always Archive, yeah, MedArchive, you could just see the paper straight away in HTML. Archive.org doesn't have the HTML, but then now they added like an experimental HTML that works. It's that empty. What's the point? Having the interface empty interface like that. I'm not sure. Yeah, there's a bunch of photos, different universities, different cameras. This would be your diabetic retina, and this is an example of a lesion using some sort of labeling algorithm. So it's actually labeling the images there. So that's nice, but we would not be going to the details unless we can get access to the dataset. It's on OneDrive. Do those actually work? It was updated 4 months ago. It's interesting. Yeah, high quality diabetic retinopathy pixel level annotation dataset. Pixel level sounds a bit over engineered, but okay. I'm pretty sure these things will require train test. You can just download without the login. Oh no, did it download into my? Let's actually try. It can just be downloaded locally, right? Seem to download. So I didn't have to log in or anything. A good thing about this data is that there's a full paper actually processing the data. So we will be trying to do the same, annotating the image, finding any abnormalities in it like they do here. It doesn't look like they're actually going into much details. Yeah, I think so if we're doing, my understanding is that if we're doing like a convolutional neural network, then it should be searching through the images, looking for similarities, so it will be giving you like a percent likelihood of the image to have this type of components, and those would be the abnormalities, and so it would be going over it and telling you, okay, in this case there is 90% similarity to the features in this sample, which is some sort of abnormality in the diabetic retinopathy, and then it will do a label on your image. So it should be pretty much straightforward. This is what we're doing here as well. Yeah, it's a convolutional neural network. There is a smaller one, so this German group, yeah, this was discontinued. It was recorded a while back, 2013. It's not a large dataset, it's about 100 megabytes of image data. Right, they added abnormalities to the whole thing. I thought I was asking just to add it to a subsection. But okay. Okay, so obviously the site is allowing ChatGPT to crawl. So I do expect it to be able to extract the data. Yeah, this is what the dataset is all about.
The high-resolution Fundus HRF image database is a publicly available resource designed to support research in retinal image analysis, particularly for evaluating segmentation algorithms. It comprises 45 Fundus images, 15 from healthy individuals, 15 from patients with diabetic retinopathy, and 15 from glaucomatous patients. Each image is accompanied by manually labeled vessel segmentation maps and field of view FOV masks. The dataset is released under the Creative Commons 4.0 attribution license, allowing free use for research purposes. Researchers utilizing this database are encouraged to cite the following publication: Budai Attila, Bach, Rudiger, Meyer Andreas, Horniger Joachim, Mikkelsen Georg, Robust Vessel Segmentation in Fundus Images. International Journal of Biomedical Imaging, Vol. 2013. For more information and to access the dataset, visit the h5.ciabihdbw research/fundus-images.
Okay, so we'll get this description for the thing. I think this one might actually be hallucinating. Just curious now. Let's see if it can. Searching the web. Okay, apparently it's legit. I'm not sure why I didn't mention it to begin with. It's sponsored by AWS. Download doesn't work. Yeah, so it looks good, but we can't actually access it, so forget about it. Okay, we need the file and folder structure. Incorrect. No, it's not capital. It should be getting this information from the same. It's like almost correct. It's hallucinating something. Okay, this is also incorrect. But no idea where it's pulling out that information from. But yeah, would have been organized better if it was this way, but no, it's not like that in the terminal. It's nice we have 4.0 embedded into Visual Studio Code now. Okay, can you go into the HRF library? Can we get the structure of the folder somehow? Okay, so we have the correct structure. There's a segmentation dataset, and then there is an image quality assessment dataset. Okay, we downloaded that one. Yes, we have the description for it. Okay, we would like... No, we would like an index HTML. Hey, we want an option to review using the folder structure below. We already downloaded. Oh, it keeps hallucinating. Yeah, we'll have this index HTML, and I don't think GPT-4 will be able to handle this. So let's go a new chat. Let's go straight for all three mini high, because this one says great for coding and logic. Yes, we do want the JavaScript, the JS. Navigate through the images. Button to toggle the visibility of the manual segmentation sounds good. I think that might be the same tomography. Let's look at the images quickly. Yes, we have those. Oh, it showed the labels. The labels, pulling it correctly. Yeah, I think that's correct. Make sure the labels are displayed on the images. That's right. Yes, we have those Retina images. Then we have one display TIFF. Yeah, mask is also TIFF. Can't show it over here. Don't know why. Yeah, images displayed in correct order. Sounds good. The UI is user-friendly and responsive. Working on all devices, including mobile. That's correct. And we're going for all three mini high straight away. Necessary at the bottom of the page. Okay. Let's do single shot prompt. Single shot. Might take a while. It might take a while. Yeah, we like the reasoning stuff.
The user asks to create an index, HTML, that will display images from the href image database. The page needs to include dataset information, such as the number of images for each category, healthy, diabetic retinopathy, glaucomatous, and how many have manual segmentation. The JavaScript should handle toggling visibility for manual segmentation, FOV mask, and vessel segmentation, along with a scroll bar for navigation. The HTML should be responsive, user-friendly, and visually appealing, with inline CSS and JS in the same file.
Sounds good. That file might be too long though.
The user asks to add toggles for manual segmentation, FOV mask, and vessel segmentation. The folders contain Manual 1 for vessel segmentation maps and Mask for FOV masks. The vessel segmentation toggle is unclear. It might refer to an automatic segmentation overlay versus manual segmentation, which is already in the Manual 1 folder. I'll assume that the manual segmentation toggle shows the manual segmentation by default, and the vessel segmentation toggle might show alternate automatic segmentation if available. There are 3 overlays: manual segmentation, FOV mask, and vessel segmentation.
Yeah, I think over here it was we only have mask and manual segmentation. I don't think there is a vessel segmentation. So it is correct in its reasoning, which is pretty amazing.
The user's request includes 3 toggles for manual segmentation, FOV mask, and vessel segmentation. However, manual segmentation and vessel segmentation appear to be the same images since both refer to manually labeled vessel maps in the dataset. I'll include all 3 toggles but have the vessel segmentation toggle duplicate the manual segmentation functionality. For the UI, I'll create the necessary HTML structure, CSS for responsiveness, and JavaScript to load and toggle images accordingly, ensuring proper layering and labels display.
Okay, we have all the images. Actually, the entire dataset. Assume we can't toggle the TIFF images are broken. Yeah, they all look quite different. Those are real images. Yeah, I'm surprised I can't toggle the. Okay, so we are able to see the images. All the images are showing correctly. The scroll bar works perfectly well. The labels, I assume the labels are correct. Now the buttons for toggling do not work. Yes, you were right. We only have the images. They are JPEG. The manual, I think it's a manual. And the manual 1 folder has TIFF files. So they are not loading correctly at the moment. When I press the toggle manual segmentation or toggle FOV mask, the vessel segmentation, it looks like a vessel segmentation, but I'm not able to. I assume it should be overlaid on top of the image. I'll share the image view and also one of the mask images as well, and let me know what you think. These are TIFF images and they're not they don't seem to be loading correctly. We'll try this second prompt. The original prompt we wrote with a GPT-4o, I assume, from within Visual Studio Code. It's not showing me its reasoning for some reason, pun intended. No reasoning, as I might not support.
Below are a few important points and suggestions to help you troubleshoot why your .tiff overlays, manual segmentation, and FOV masks are not appearing on top of the base JPEG images in the browser. Most modern browsers, Chrome, Firefox, Safari, Edge, do not natively support the .tiff image format in less than img greater than tag. That means even if the file paths are correct, the browser will fail to display the TIFF overlays, resulting in a blank, empty overlay when you toggle them on.
Yeah, the TIFF is not loading. It seems to load okay, but not actually showing. Yeah, I'm looking at the network. There's no errors, and also the TIFF files seem to be loading, but they're not showing. Interesting to convert. And can you comment why are those TIFF files to begin with and not JPEG? Surely there's a reason for it, because if there is a good reason for them being in this file format, then converting does not make much sense, does it? Yeah, hopefully next time with this dataset we'll get to training.
Below is a brief explanation of what you're seeing in the attached screenshot and why the HRF dataset uses .tiff files instead of JPEG for the manual segmentation and FOV mask images. However, you're not actually seeing the segmentation or mask overlaid on the base Fundus image in the browser, because most browsers do not natively decode or display TIFF images in less than IMG greater than tag. Even though the files are being loaded successfully, the browser can't interpret them for display.
Okay, that's a problem.
Medical imaging datasets commonly use TIFF or other lossless formats for segmentation masks, especially when lossless storage. TIFF is typically stored without compression or with lossless compression, ensuring the pixel data for the masks is not degraded. JPEG is lossy, which could introduce artifacts or blurred edges in segmentation data. Bit depth. Some medical images or masks can be 16-bit or higher, grayscale. TIFF handles higher bit depths easily, whereas standard JPEG is 8-bit and lossy. Established workflow. TIFF is widely supported in scientific medical image analysis pipelines, e.g., ImageJ, MATLAB, Python PIL, etc., so it's the de facto standard for certain types of data. Thus, the HRF dataset authors likely used TIFF for technical precision and to maintain the integrity of segmentation masks. They are not meant to be viewed directly in a standard web browser as you would a JPEG photo.
That should be fine if we have a JavaScript library. So if I have a JavaScript library, I don't want to change them into a different file format.
If you need to see the masks, segmentations overlaid in a normal browser-based viewer, you have two main options.
Yeah, we don't want to convert.
Use a TIFF decoding JavaScript library.
This library actually working.
This lets you keep the TIFF format without needing conversion. The downside is a bit more coding overhead. You can't just do less than img src equals TIFF greater than. You must load the file as binary and draw it to less than canvas greater than.
I think it will be worth doing, again, because there is, assuming there is a reason why it's TIFF to begin with. I mean, no, we don't want to convert it into a lossy file format, do we?
Even though the dataset authors had good reasons for storing the masks in TIFF, for web display it's quite common to convert them to PNG. PNG is also lossless and preserves 8-bit grayscale data accurately. As long as you aren't losing any crucial bit depth, for example, if the TIFF is 16-bit and you only need an 8-bit black-white mask, PNG is sufficient.
I don't know how many bits the TIFF files are. Yeah, the TIFF files are coming directly from a Canon AOS 20D. There was something done in Photoshop, which will be crazy. Okay, the bottom line.
Keep the .tiff files for your actual image analysis or research, where you want the full fidelity. For a web-based demo or viewer, use .png overlays. That way, your toggle buttons will work as intended, and you'll actually see the overlays.
Too long, don't read.
Your screenshot shows that TIFF files are being fetched successfully, HTTP 200, but not displayed because browsers don't natively render TIFF. The dataset uses TIFF because it's lossless and common in medical, retinal image analysis. To see the overlays in the browser, either convert them to PNG or use a TIFF decoding library in JavaScript.
I think the TIFF decoding library, I want to keep the images as they are, so the TIFF decoding library should be fairly straightforward. Yeah, because the images seem to be coming directly from a specific camera, so I don't want to mess around with the images. I want to keep them as they are.
Why TIFF? TIFF files for medical images, lossless. TIFF supports lossless or uncompressed storage. In medical, biomedical imaging, it's critical to preserve exact pixel values, especially for segmentation masks, so no artifacts are introduced. High bit depth. Many TIFF files can be 16-bit or higher. While your masks may only be 8-bit, TIFF remains a standard in medical imaging software pipelines, e.g., ImageJ, MATLAB, Python PIL. Precision and metadata. TIFF can store additional metadata, e.g., camera model, capture settings, and handle multiple pages or channels. Because of these advantages, datasets like HRF often publish the ground truth masks in TIFF. However, most web browsers cannot directly display TIFF in less than img greater than tag. They fetch the file, status 200 OK, but fail to decode it, leaving a blank or broken image in your viewer.
Hey, you gave me the wrong library. Can you check this URL and update accordingly? Also, let me know if you're able to pull all the necessary data from the URL, or do you need the actual text from it? Yeah, because that one is important. Yes, we're loading TIFF files correctly, JPEG correctly. Yeah, we want to overlay them properly. Not sure if it browsing. It doesn't show me the reasoning anymore, which is a bit annoying. What are you talking about? It should be simpler than that. I didn't actually look at the page. Let's downgrade for a sec to GPT-4. Oh, I needed to actually browse that page. Yep, now it's searching the web. Okay, is this the correct URL? Are you kidding me? It explicitly says it's hallucinating on me. You cannot read the site. I don't know if that site doesn't have permission, but then it should just say so. Okay, now it's using the correct one. Yeah, that's the correct one. It's just loading images. Didn't expect that to be a problem. Okay, did the snippets, but I would not be able to integrate them myself. Let's move back, go back to O3 mini high. Yeah, we're using this JavaScript library to load the TIFF file.
I need to create a complete HTML document for this. I'll include a head with the title, MedArchive and viewport. Also, the style sheet, either link or inline. The most important part is pulling in the TIFF library via the less than script greater than tag and incorporating the function load TIFF to canvas. I need to make sure to also include code for create image container, the toggle buttons, event listeners, and the populate gallery function. It'll take a coordinated effort to include all those parts. Let me work through the full code.
You can do it.
Below is a complete example of an index HTML file that uses the correct TIFF library from JS Deliver to decode and render your TIFF overlays directly onto canvas elements without converting the files. This example includes all the necessary HTML, CSS, and JavaScript code. You can save this as your index HTML file inside the href folder. HTML, copy.
Yeah, let's see. Looks like... Wait, that file is definitely there. That's hallucinating on me or something. Is it case sensitive? Why on earth? Some JPEG. Okay, some of the JPEG file names, the actual JPEG is in capital. Like this, and some, I don't know. Why on earth? Hey, can we address it in the code as well? And let's get back to 4.0. It's like that in the original data. I didn't even notice it. TIFF. Yep, some have kept it. I'm pretty sure that's what the problem is.
Good catch. Since some of the JPEG file extensions in your dataset are in uppercase, JPG, and some are in lowercase, .jpg, we need to handle this properly in our code. We will automatically determine the correct file extension based on the category, Dr. G, H, by modifying our JavaScript.
That's working. Not toggling the mask. Okay, let's clear the console. Okay, we're having trouble loading the... Okay, now all the JPEGs, so the original images are loading. All the original images are loading correctly, but I'm still getting these errors, and there's still issue with the TIFF files. I'm not sure what the problem is. Can you... All the images are loading. There was separate issues. Separate issues.
The function TIFF, decode, is not recognized, which means the library might not be properly imported.
Make it globally accessible. We need to import it in the JavaScript. It's an ES module. It's not the JavaScript. Do I just pop it in? Do I just pop it in the screen like this? Correct.
Date index, HTML to include the S module import. Checkmark modify your TIFF decoding function to use window, TIFF, decode. Checkmark reload the page and check if the TIFF overlays now load properly.
Yeah, tried the best to do it myself, but no luck.
The error occurs because you cannot use an import statement inside a regular less than script greater than tag in HTML unless you specify type equals module. However, modules do not work well with inline scripts unless handled correctly. Instead of directly placing import inside a less than script greater than, you must define a separate module script and reference it. Step 1. Keep the HTML file as is, but remove the import inside the less than script greater than tag at the bottom. Step 2. Create a new script, JS file, or inline it properly in HTML with type equals module.
Yeah, I think it's updating the whole code for me again. And this is for all. We did use O3 mini high at some stage. It seemed to be, yeah, it is better at coding. And that's for sure. And now we're splitting.
Step 1. Keep the HTML file as is, but remove the import inside the less than script greater than tag at the bottom. Step 2. Create a new script, JS file, or inline it properly in HTML with type equals module.
Yeah, we have script.js as well. Okay, that's just in case we want to redo the code. Okay, the good thing now is that the HTML is only 50 lines. We split the JavaScript. Why not there's index.js? Is this one? I can bring in a stronger model. I give it the error message, see what we get. This might be a longer process. We haven't started the training. Hopefully next time we can actually train a neural network, a convolutional neural network on this data. It's not a big data set, but we want to display it correctly.
When you see the error uncaught reference error, exports is not defined in the browser console. It typically means that the JavaScript file you are loading is a common JS or Node style module. Using exports, which does not work directly in the browser unless you bundle or transpile it first.
The problem with O3 Mini is that I'm pretty sure it doesn't have internet access, so it's not searching. It's not searching the web.
Fortunately, the TIFF library also provides a UMD build that works in the browser without bundling. You can load it via normal less than script greater than tag, and it will attach a TIFF object to the global window scope.
Yeah, now it's telling me to go back and use the previous thing. Yeah, we have trouble with libraries. I think it will actually be worth instead of using a library, can we actually import the TIFF manually and display on the page without using external library? Why is it not simple?
The user wants to know if they can display TIFF images on a page without using an external library. The problem is, browsers don't natively support TIFF images. So, the best answer is, it's not possible to display TIFF in a browser without using some kind of decoding library, unless you convert it to a supported format first. The user might be asking if they can manually parse the TIFF, but that's not so simple to do. Browsers don't natively support TIFF images, so if you want to display them, as is, without converting them or using an external library, you'd need to implement a TIFF decoder entirely in JavaScript. This means manually parsing the binary TIFF data, its headers, tags, and pixel data, and then rendering that pixel data to a canvas or converting it to a format the browser understands. TIFF is a very flexible format that can store images in various bit depths, with multiple compressions, LZW, deflate, etc., and even multiple pages. Writing code to handle all of these possibilities is non-trivial.
I get stuck because of this external TIFF import library. Like a few steps, tried with 4.0, well, because I think it will just follow instruction, not be smarter. Giving me wrong libraries, and I'm using a different CD, and yeah, I'll just continue next time. Yeah, we're having trouble with libraries and the like. Hey, go check out the website. Let me know what you think. Everything we do eventually appears on this site. So stay tuned.